Okay, hi everybody. We're going to talk about geometric distributions. This is section 8.2. We're going to take this section very, very quickly. There's not a lot in it that's important for the AP exam. The concepts are very straightforward, very simple, so I want to give it a pretty quick treatment. So here we go. First of all, a geometric distribution starts with the Bernoulli trial. Now we have this definition from 8.1 as well. This is, remember, a definition that's not in your textbook, but is one that I like using. And the concept of a Bernoulli trial, again, is just the situation where you have two outcomes, okay, success and failure, and they're independent of each other, so we can repeat it over and over again. That's a Bernoulli trial. The binomial setting, if you recall, is where I have a fixed number, and I count how many successes out of that fixed number. That's the binomial setting. The geometric setting is very similar, but we're counting something different. So we have, again, part one here, we have each observation falls into one of two categories. We call success and failure. The observations are independent, and the probability of success, call it P, is the same for each observation. 1, 2, and 3 are all basically just saying the same thing as this is a Bernoulli trial. Number 4 is what makes this geometric. The variable of interest is the number of trials required to obtain the first success. That's a geometric distribution, a geometric setting, okay, as opposed to a binomial. Okay, so when we're talking about the distinction between the two, we'll get into this more. A binomial says how many successes out of n trials. Okay, and this is you should probably put this in quotations. This is not exactly what it's doing, but again, if you're trying to get a sense of which one is which, binomial is how many. Geometric is how long until a success. Okay, so that's kind of what we're looking at here with a geometric distribution versus a binomial distribution. Again, we're not exactly counting how many or how long. It's set up a little different. Binomial is saying the probability of x being something is the chance there are x successes, okay, and geometric is the chance the first success happens the xth time, okay. But again, if you want to come up with a way to kind of remember these, binomial is how many out of a fixed number of trials, and geometric is how many trials does it take to get there. Okay, so let's talk about a simple situation where you're rolling a die, and the chance that you roll a 3 on your 4th try. That's your first success. Okay, so first verify it's a geometric setting and define the variable of interest. Well, is this geometric? Okay. Well, first of all, do we have a Bernoulli trial? We do. Okay, it's rolling a die. It's a repeatable event. We have a notion of success. A success is rolling a 3. Okay, what's the chance of rolling a 3? Okay, chance of rolling a 3 is 1/6. Okay, that's fixed. They're independent trials. Good. And what are we trying to figure out? We're interested in the probability that our first success is the 4th try. So we're interested in the chance that it takes 4 rolls to get a success. That's what a geometric does. Okay, so if I were to just to do a quick example here, and I roll a die 4 times, roll, 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 okay, it's the chance that if I roll that die 4 times, like I just did, that 4th roll is the first time I see a 3. Okay? Alright, that's what we're looking at here. As opposed to binomial, where we might say something like, roll a die 4 times. How many 3s do you get, or what are the chances you get a particular number of 3s? That's the distinction. Okay, so we want to figure out what are the chances that if we roll a die, the first time I have a success is the 4th roll. Well, what's the probability? This is actually not a hard probability to figure out. We know the chance is 1/6, okay, for each individual roll. So the first time I don't get a 3, so that's a failure. The chance of not rolling a 3 is 5/6. The second time I don't roll a 3 either. That's another failure. The chance of not rolling a 3 is 5/6. The third time, again, I fail, 5/6. And the last time I succeed, 1/6. So my probability is simply 5/6, 5/6, 5/6 times 1/6, and that's it. Okay, so this is not a terribly complicated formula, nothing like a binomial distribution. All right, so here is the formula written out. Now, here's one of those formulas where I would say it's probably more important that you're able to describe exactly how this works. Okay, remembering this formula, memorize this formula is not as helpful, frankly, as being able to think out fail, 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 success. So as we just did. So let's look at this. If we have a geometric distribution, we have a chance of success. That means 1 minus that number is the chance of failure. And the possible values of x are any positive number, because you can continue to do your trial over and over and over and over again. We're interested in the nth, okay, trial, and we say the chance that my first success is the nth trial. Well, that's going to be given by 1 minus p to the n minus 1 times p. And all this is, okay, p is x equals n. All this really is saying is chance of failure raised to the number of failures chance of success. This is all it is. Because how many times do you fail before you succeed? If n is equal to 5, that means you fail, 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 fail. That's 4 times, 4 failures, and the last time, number 5, is a success. That's all it is. This formula does not show up on the AP exam as a formula because they assume that it's too easy. You don't need to memorize it. Okay, here's a good example of a problem. Testing hard drives. So we have data that suggests that 3% of a company's hard drive are defective. You've been asked to determine the probability that the first defective hard drive is the 5th one. Okay, so first of all, verify it's geometric, identify the random variable, write x is the number of blank, and fill in the blank. Okay, what constitutes a success in this situation? So here, x should be the number of trials until we get a success. Well, what's the success? Okay, well, a success is a defective hard drive. So x is the number, okay, of hard drives tested until a defective is found. Okay? Because in this case, a defective hard drive is considered a success. So what's the probability that the first defective hard drive is the 5th one tested? So what is the chance that x equals 5? That means the first 4 were not defective and the 5th one was. So this is as simple as saying, well, the chance that we have a defective hard drive is 0.3. That means the chance of a not defective hard drive is 97%. Well, how many times do we have good hard drives? When we have that 4 times, the 5th time is the defective one. So we say 0.97 times 0.97 times 0.97 times 0.97. So 0.97 to the 4th power, pardon me. And the 5th time, finally, we get the defective hard drive. Okay. And we could quickly do this. I'll pull up my calculator here. We could quickly do this and get an answer. Okay, so we're going to get 0.97 raised to the 4th power times 0.03. So 0.026. And you have to think, does that make sense? Well, if there's only a 3% chance that a hard drive is actually defective, then in general, if you only test 5 hard drives, it's not a great chance you're going to find one that's defective. So there's only a 2.6% chance that your 5th one is your first success. Okay, that's pretty interesting, right? Okay, now let's look at the expected value and the standard deviation. Now I'll say a couple things about this. For the homework, I'm going to ask that you need to know these formulas, okay? And particularly you need to know the mean. The standard deviation is much less important than the mean in terms of the AP exam, but the mean is actually fairly important. Even though it doesn't necessarily show up on the AP exam every year, I think it's one of the few formulas that's not explicitly mentioned as something you need to know that they would actually put on an exam for you. The standard deviation I don't think is terribly important in some ways. So the mean of a geometric distribution is 1 over p. What does that mean? Okay. That means if we're looking at the number of trials until a defective hard drive, okay, then what we're looking at here is the mean is the average number of trials until a defective hard drive. Okay. Let's look at this formula here. Okay. The formula is the mean is 1 over the probability of a success. Let's take a look at the defective hard drives. Defective hard drive problem, the probability was 0.03, which is 3/100ths. Okay. All right. So what we have to do here is say, well, if we have 3 out of 100 as our probability, okay, then on average, if those 3 hard drives are spaced out kind of on average over the 100 hard drives that I test. Suppose I test 100 hard drives, and suppose in those 100 hard drives that, well, it's reasonable to say that on average 3 of those 100 are going to be defective. That's what this is saying. If I have 100 hard drives, on average 3 of them will be defective. Well, if 3 out of 100 are defective, and you have no way of knowing where they're going to show up, okay, in the order of 100, then I'm going to expect that about a third of the way through my 100, I'm going to reach my first defective. And another third of the way through the 100, I'm going to reach my second defective, and so on. So what that means is the mean is going to be 100 divided by 3. Okay? So if the probability is 0.03, then the reciprocal of 0.03 is the same as 100 over 3, which is 33.3. On average, it should take me about 33 trials until I am not guaranteed a success, but until I'm pretty likely to have gotten a success. It'll take me about 33 hard drives because on average, there are 3 hard drives for every 100 hard drives. 3 defective hard drives for every 100 hard drives tested. Okay, and that's where this idea comes from. So all you have to do to find the average or the expected number of trials for a geometric distribution is flip over the probability. Okay, the probability was 0.03. That makes the expected number of hard drives 33.3. All right, and that's it. So we're going to do some practice with these next time. Thanks, guys.